Hello everyone, this is the video lecture for Calculus 1, section 6.2, disk and washer method. I never use the washer, well I do use the washer method, but I don't use the name for the washer method. I always just say disk. I just say disk method. And it will become more important to differentiate between disk and shell method. That's not up here. Shell method is 6.3. But as we progress on, you're going to have to use both, one here, one there, etc. And so later on, I will just differentiate it by saying disk or shell. And that confuses some folks that have not had me. That's why you're having me, and that's great. I say disk and shell. Washer is just disk. These are the same. Okay, so I just say disk and shell. Okay. All right, so there is a washer method, but they're all the same. Let me just go ahead and show it to you. Volume is equal to pi times the integral from a to b of capital R squared minus little r squared dx. And this is when you want to revolve something around the x-axis. Well, there's your formula, and obviously the video keeps going, so there must be more to it than just this. We got to actually do stuff. And so, yes, let me give you a good example. In fact, I love this first problem. It's a great first problem here. They got y equals x plus 1, y equals 0, x equals 0, x equals 2, and they say rotate about the x-axis. Now, what if they didn't say x-axis, but they said y-axis? Well, that's another problem. Right now, this is our formula, so we could do this. So what is capital R, little r, and pi, and all this other stuff? Well, capital R is what I would like to say my top, and little r is my bottom. And so you could technically rewrite this as pi integral of top squared minus bottom squared dx. And wow, that's starting to look a lot like the last section we had, right? And so the same skills that we've been using to find the top and bottom are important here as well. I more likely will be continuing to use top and bottom because that's how I think about it, and that's the way it should be. And capital R, little r are just ways of expressing top and bottom. So in order to know the top and the bottom, if you didn't know that from the last section, is that I basically graph it every single time. And we got x equals 2. And so we have this area right here. And so you can see that we have our top. And our bottom is going to be a 0. Okay, awesome. Top and bottom. Okay, we can do this, but now what we're wanting to do is not find the area, we want to find the volume. This is a volume here, and so we're rotating it about the x-axis right here, and we're trying to find the volume of whatever that shape is going to be. So I like to draw pictures, because that's what we do here. What's going on is that you're making a kind of like a cone. I think it's called like the frustrum or something like that. I'm not entirely sure. But it's cut off, and there's your x-axis, and then it's coming out the other end, and that's what you're rotating here. And so you can kind of see this three-dimensional shape that we're going to have as we take this and rotate it around my x-axis. Another version is that you can have it up here. Now it's kind of like a pyramid thing. There you go. So again, we're just revolving it right around there. We could redraw this as many times as you like in different ways, but the idea is that this is a three-dimensional object, and what am I trying to find? I'm trying to find the volume. What if this was full of concrete? And this was like a pillar that I had to go and find and all that stuff. How much concrete, how much volume would be needed? And so, this is a very simple formula. We already have the top and the bottom. There's my top, there's my bottom, and there's my limits. And here we go. So volume is equal to pi times the integral from 0 to 2 of my top squared. So that's going to be the x plus 1 squared. And then my bottom's the 0 squared. Dx. Done. This is practically all we have to do. Now is the easy part. There are a few ways to go about doing this. This obviously goes away. You could FOIL this thing out, x squared plus 2x plus 1, and then you integrate all those things, polynomial, blah, blah, blah. But if you did a u sub, your du would actually be dx, and therefore you don't have to change much. Simply put, there are quicker ways to get this problem done without having to go through the monotony, okay? I just skipped ahead. Now, I kind of explained it, but really what I'm wanting you to do as you continue on in your calculus career here is that I want you to see me taking only a few milliseconds to get these things done. I want you to see me doing these shortcuts. And I'll try to explain it to you about what I'm doing every time, but I can't every single time. I want you to find a style for you. If you like shortcuts, if you want to just, go from here to here, cool, do it. That's the point. That's what I'm trying to train you on, kind of. But doing it the long way is fine, too. And that would mean doing this thing, or doing this thing, and all of that stuff. There's a lot of ways you can go about doing this. Up to you. Find something that works for you. I'm just showing you something that I know. Make it faster. Okay. When I plug in the 2, you get a 3 cubed. And when you plug in a 0, you actually get something. You get a 1 cubed. And when you put all those together, you basically get 9 pi minus 1/3 pi. And that makes 26 pi over 3. And there you go. The first problem's done. Okay, so let's keep going. I'm going to try to focus more on just doing this disk method stuff. And that'll be great. Okay. Again, I'm just going to write x-axis, rotate it around the x-axis. So what's the shape look like here? We got a square root that's been shifted a little bit. So he's like right here, shifted down to 1. We go to x equals 4, which I'm trying to make a vertical line there. There you go. So we want all this, and we're revolving around the x-axis. And so what is the shape going to look like? Well, it looks kind of like, I don't know, like a this. Like a hat, kind of. Like a little silly hat. There's your axis going from here, and it pops out the back end over there. Another way is that it's kind of like a hill, I guess, like a hill. So I'm wanting to draw this for you because it's important. I'm not the best drawer. I'm not the best artist here. But I'm trying to show you the shape here of the volume that we're trying to find. We'll be doing a lot of this in Calculus 3, which you're going to be taking with me, right? Let's do this thing, and this is actually very simple. Top, bottom's 0. Here we go. Volume is equal to pi times integral from 1 to 4 of my top squared minus my bottom squared dx. Obviously, you don't need that. Square and square root cancel. And so we're left with something very simple. So pi, and then we got x squared over 2 minus the x from 1 to 4. And you plug all that stuff in, you get 9 pi over 2. So I'm skipping to the end there. There you go. Okay. Now they want to throw some weird problems at us. X equals 2 square root of 7y. And x equals 0. And y equals 3. And they want to go about the y-axis. Let's draw the picture. So x equals, you know what? I'm not very good at drawing this stuff. Here, come on. Go ahead and tell me, what does this shape look like? Well, you got to do some math, and then you can figure it out. And oh my goodness, it's a parabola. Which is fine. I yeah, I guess I'll do that with you. I'm not no, I'm not doing this with you strictly because you're Cal 1 and I'm assuming less of you. That's definitely not the case. I mean, you're doing Cal 2 work right now. Just to be straight, you're doing Cal 2 work right now. We just call it Cal 1 for some reason, and that's fine. Um, so it's a parabola. There you go. I just sometimes I guess I could see it without having to do it, and I would like you to be able to get to that point at some point. Oh, you're the teacher, da da da. I mean, no, it's not the point. I guess a lot of training would be helpful, of course, but you're just as smart as me, probably smarter than me, and so you can do this without having to do it eventually. Okay, eventually. Okay, keep moving. Um, and so we got this parabola. We got y equals 3, which would be right here. And then x equals 0 is right here. So really, they're just wanting this stuff in quadrant 1. And they say rotate it around the y-axis. Now, that is something I do not yet have the ability to do. Kind of. What if instead I were to redraw this like this? I take this shape, and I draw it like this. This is now y. This is now x. Do you see the shape now? I just redrew it. I guess not. I didn't rotate my axes. I flipped my axes. X and y and x. Very similar to an inverse. And so this is what I'm really looking for. And then we can go from there. Well, okay. If I see it like this, then let's go and do some problem here. My volume would be pi integral from 0. That's obviously 0. What's this right here? Well, it's 3. And then I now need to find top and bottom. Top, bottom, super easy, 0. My top is going to be blah, blah, blah in terms of y. Because these right here, 0 and 3, those are y values. So blah, blah, blah in terms of y. It's actually the original right there. I didn't put the 0 because it goes away anyways. In a way here, you didn't have to convert anything because that was just to show a picture. Aha, thank you. But really, yeah, I got to actually do something else. This squared is going to apply to everything here. So that's going to be a 7 and a 4 makes a 28 pi. 0 to 3 of simply y, because you can see the square root and the square are going to cancel. And so that's going to be y squared over 2 from 0 to 3. And so then that's going to be a 14 pi times 9. And that's going to equal the 126 pi. And there you go. I've had a lot of folks have difficulty with this right here. And so I'm just going to real quick, briefly talk about it. What I'm doing is an inverse, okay? So about the y equals x line, all I'm going to do is switch x and y. And so this is my new one here. And so I have a point here, let's say, at that's 0, 3. So then here, I better have a point at 3, 0. Here, I have a point at, I don't know what that's going to be. I have no clue what that would be. Because I'd have to set it equal to 3, and it's going to be something weird. I'm just going to call it Q, 3. And so then I have here 3, Q. There you go. We have 0, 0. So I'm going to switch my x and y, and guess what? Yeah, it's 0, 0. You can start creating this shape for yourself by looking at individual points. That's my recommendation. But just start to work on that, because that's important. You'll be doing that in Calculus 2 as well. 62019. I got y is equal to x to the 5th. I got y is equal to the square root of x, and they say go about the x-axis. I'm going to just draw this picture, if that's okay. We got x to the 5th, and then we got the square root of x, and I'm guessing they just want this area right here. The problem is I don't know where they're going to collide, and I believe the answer is going to be a 1, but let's just find out. So x to the 5th is equal to square root of x. If you square both sides, you actually get 10, and then don't cancel, you factor out an x, leaving you with 0, and x to the 9th equals 1. The 9th root of 1 is a 1. 0 and 1. So that's a 1. Okay, top and bottom, top and bottom. So and I'm revolving around the x-axis, so volume and all that kind of stuff. And so pi integral from 0 to 1 of my top squared, and then my bottom squared dx. Some of this is easier than others. We got a plain old x. We got an x to the 10th. I wonder where I've seen those before. So that's x squared all over 2. This is x to the 11 over 11 from 0 to 1. Plugging into 0, everything goes away. Plugging into 1 gives you those fractions. 9 pi over 22. Cool. All right. Next one, 62016. I got 2x is equal to y squared. I got x equals 0, I got y equals 5, and I got about the y-axis. Oh, again, why thank you so much. This is what I do. So x is equal to y squared over 2, and I see this as a y and an x automatically. Draw this as you normally would. Don't think of it like silly. Just something squared over 2. It's a parabola, isn't it? Now what's going on? And then we got y equals 5. That's a y. So 1, 2, 3, 4, 5. There you go. There's your 5. X equals 0. That's going to be this guy. And oh my goodness, I got my area. And then I'm supposed to go over about the y-axis, and that's going to be this guy. Oh my goodness, it looks perfect. That's just what I wanted. But no, my letters are mixed up. No, I can't have that. Don't care about your letters. Look, let's do a U and a V. Now everyone's happy. My point is, draw it as you need. This says rotate around the y-axis. Do you got a formula for that? Do you got a formula for that? No, you don't. You got a formula for x-axis, or rather would I say horizontal axis. So draw it that way. This is what you're revolving around. Start over here. And from there, build out. Very important. So top and bottom. Y squared over 2 is on my top. And of course, all that's squared. And my bottom is a 0, which goes away. And so now I technically have y to the 4th over 4. Why did I put a dx? That's a dy. Sorry. I make mistakes too, of course. Like, all the time. Y to the 5th over 5 from 0 to 5. The 0 will obviously cancel. And so we got pi over 20 times 5 to the 5th power. I'm like looking down like, is that for reals? Yes, actually it is. You get 625 pi all over 4 when it's all said and done. So there you go. Let's just draw a picture of this one. I should be drawing pictures of each one of these, honestly. So we've got this kind of curve thing, and we're going to revolve it. So it's going to have a curve thing here too. And so looks something kind of like that. I wouldn't call that a cone. It's more like a tent. You know, like an old school kind of tent thing. There you go. And you're revolving it around this guy right here. There you go. Looks like a tent. Okay. Now, most of the problems in this section are easy breezy. There's a couple that are a little strange, and I believe that these two here are that. Okay? Now, they will try to be confusing, and I do not like them trying to be confusing. But we're going to get through this together, okay? So this is a 2, and this is a 1. I know. You're thinking, that's not the scale. Yeah, I know. I'm not the one that makes this up. Okay. And they want this area here, and they say that this curve is 2 times the 4th root of x. Of course. I mean, that's what you were thinking, right? So they say find the volume as you revolve it around this line here. And they're not going to make it so easy as x and y. They're going to say the OA line. I don't know. Just do what you got to do, you know? This is what it is. It's an x-axis. It's not going to be too bad. Notice that my top is a 2, and my bottom is this curve, okay? So volume is going to be pi integral from 0 to 1. Top is a 2, and bottom is this 2/4 root of x business. Still all squared. And so what we have is a 4, and then we got a 4, and then we got an x to the 1/2 of all things. So that's a 1/4 times a 2 makes a 1/2. Okay. 4x, 4, add 1 to the power, divide by the new power, from 0 to 1. The 0, of course, cancel everything out. That's nice, thank you. I'm going to pull a 4 out because, well, I can. 1 minus, and that's going to be a 2/3, again, times the 1. So we got 1/3, and so 4 pi over 3, and yes, that's the right answer. Cool. It's not too bad. 62038. This is a similar style problem, but this one's more annoying. And I do believe that this one's in Cal 2 as well, because I had a lot of my Cal 2 students being upset at this problem. And it is completely understandable. They want you to revolve around this axis this time, and it's the same setup, 2/4 root of x. This line right here is actually just 2x. And that's nice. That's so nice. What we really want to do is convert these into x equals, because do you have a formula for this y-axis rotation? The answer is no. That's coming up in the next section in 6.3. That's shell method. Okay, I do not have that formula yet, and so I'm going to just do it the long way. And so this is the 4th root, so 4th power of both sides, and you get y to the 4 power, and then 2 to the 4th is a 16. Same thing here. You get y over 2 is equal to x, so that's actually already done. This is going to be your top, this is going to be your bottom, and here we go. So integral of pi times, okay, so pi times integral of 0, of course, all the way to 2. Okay, you want me to redraw it? Just, here we go. There you go. See, now it's the x-axis stuff. Okay, top is going to be, actually, was I mistaken? You know what? Perfect opportunity. Perfect opportunity. So this is not my top. This is my top. This is my bottom. I should have drawn it, but I was a little too quick. I was a little too quick. I should have drawn it. That was my fault. But let's say that I messed that up anyways. Let's roll with it. This is a perfect opportunity to learn. Let's say that this is what I'm going to choose. I'm choosing these. Okay? I know I'm wrong. I'm looking down at my notes. I'm wrong. I get it. I went too fast. I said to myself, I don't need to draw that other one. I already know what the top and bottom are, obviously. See, I was being too hasty. I'm getting it wrong. But I'm doing this on purpose because it's a learning lesson. So, and you're like, wow, guy, seriously? And yeah, I am serious. We're going to keep going. This is wonderful. That's going to be just a 5. And so then y squared over 4 now. 2 and 2 makes a 4 there. From 0 to 2. 0, of course. Here we'll cancel everything out, and so that's nice. 5 times 16. Hold on. Because I'm getting it all wrong. I don't have my notes, obviously. So I got 80. Do I? Okay. Oh, I did it differently here. I did it differently here. Or did I? Pause. Pause. No, I'm doing it totally wrong. Back up, back up, back up, back up, back up. I was so focused on getting it wrong that I actually really legitimately got it wrong. Okay, so hold up. Pause for a second. Yeah. Top and bottom, they're going to be wrong because I chose that. Guys, I needed to square these. Oops. And that happens. Did I see on the last one? Did I square? See, I squared them. That's the formula. So I was so focused on showing you my error that I made another error. So what's 16 squared? Now here's the thing, guys. I mean, I'm just a human like you. But at the other time, I guess, this can happen to anybody. You know, what if you were getting distracted by the dog or something at the time, or one of your kids comes in the room and you just forgot to square something, right? It happens. It happens. And so now I'm going to add 1 to the power and divide by the new power. And so I want to know, what is 256 times 9 is 2304. We got cubed over 3. That'll make a 12 down there, of course. And then 0 to 2. Okay. Plug into 0, of course, to cancel everything. Plugging into 2 is what we're really after. And so I'm going to get 2 to the 9th over 2034. Nope. Dyslexia. Hold on. 2304. And then 8 over the 12. And again, the zeros all cancel and stuff like that. And I'm gonna actually do this one in my calculator because I know I'm getting it wrong on purpose here. Just as expected. Negative 4 pi over 9. Oh yeah, we did it. The answer is 4 pi over 9. Positive. Okay. What just happened here? Besides all my error, let's go recap for a second. I was going through and finding this, and I don't have the y-axis, so I need to flip it. So I flipped it, but in my haste, I didn't recall my top and bottom correctly. I said this was my top and this is my bottom, which are actually wrong. But I chose to go down that road anyways because I wanted to show you something. Blah, 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 blah. And we get a negative volume. Is that possible? No. So just make it positive. And then you're done. So switching your top and bottom is not actually very detrimental to the problem itself. It will become very apparent in the end. So do not worry about those smaller things, okay? Say, well, I can't remember what's on the top or bottom. Just put them both in there. It'll be fine. Just at the end, if you see something weird, just make it positive, okay? So there we go. We learned. That was a learning lesson. And let's not do that again. So base of solid has a boundary curve of 49x squared plus 4y squared is equal to 196. So this is the base of a solid has this boundary curve. Cross sections are perpendicular to the x-axis. They are isosceles right triangles with hypotenuses. The hypotenuse is the base. Okay, I cannot write all that English here. That would take forever. Find the volume. So go to the homework, pull this one up, and kind of like go along this with me, okay? It doesn't have any pictures as far as I know. It's all just very strange. Has nothing to do with disk and shell method and all that. And so what's happening is that we have an X, and we have a Y, and we have a Z. And there's this shape, if you see this right here. This is it's going to be a Y major, so it'll be more like this here. Some kind of ellipse. And they're saying that the cross sections for the volume are going to be right isosceles triangles. And so they're touching tip to tip here. And they're making this shape. Are you seeing the shape that's coming about? Now, it's a funky shape. It's a funky shape. Here, I'm just going to say he'll disappear in the back there and all that. Okay, so... and then it kind of makes this arc. Let me use a different color for the arc. Hold on. It makes this kind of arc here, like this. Okay. So, it's kind of like a wedge. It has this semi-sharp edge here. But it's not super sharp like a knife. It's like a right angle. But then it kind of it just smooths out on both sides. So it's like a pyramid, but it's kind of lumpy. If you're seeing it from the side, it looks kind of like this. But if you're seeing it straight on, it looks like this. Okay, so that's facing it from this way. It's right here. If you're facing it from this way, it looks like that. Okay, it's kind of weird, but there you go. Okay. So what in the heck are we supposed to do to find the volume? I know. That's why we're doing this problem, okay? That's why we're doing it. So each one of these... oh, man. Okay, each one of these right isosceles triangles looks like that. What's going on is that this is a y value here. And if you cut this straight down the middle each time, it would be on the y-axis. And so what I'm doing is I'm seeing just like, let's just say this triangle here. I've got this little bit right there. Well, that's going to be this right here, okay? So the full distance is going to be a 2y because this is going to be a y value out here. You can see that it's a y value. And so there's two of them because you got 1 and 2. And then this is 45 degrees for sure. This is 45 degrees for sure because that's a 90. And so you can use sine and cosine and all that to find that each one of these sides is 2y divided by square root of 2 and 2y over the square root of 2 for the length of those sides. Now I want to find the area of just one of these triangles. If I can find the area of this triangle here, then what I do is I just say, well, there's an area here, and there's an area there, and it's like all these little slices. Actually, that's the wrong way to slice. It's going to be slices here. Slices here, all these slices, all these triangles, and guess what you're doing right now? You're finding the volume. Wow, it's like Riemann sums. So, okay. So what's the area to all this right here? Half base times height and all that stuff. Guess what? It's just y squared. Yep. Isn't that so funny that it's so easy? And so here you go. Volume is going to be equal from A to B of area dx. You know what's funny is that we actually have a lot of these answers already. What's my area is y squared for each single one of those. Dx, okay, dx. I don't know why. Yeah, we're good. We're good. And then my y values are going from here to way over here. Well, to find the y values, you set your x equal to 0 and solve for y. So you divide. Y squared is equal to calculator 49. Square root both sides, and then you get the plus or minus the 7. Okay, so we're technically going from negative... Hold on. Why do I have 2? Oh, sorry. Pause. Hold on. Yes, if you set x equal to 0, you're going to get 7 and negative 7. Guess where that is? Right here. 7, negative 7. Okay, that's fine, but that is not what we're doing here. We want this this value right here, all the way over here on the x, wanting x. So that's not bad, but it's not required. So in the other way, sorry, we're going to set that equal to 0 and solve for x, and yes, you get plus or minus 2. So this is a 2, and this is a negative 2. Okay, because again, my formula was this guy. So negative 2 to 2, and here you go. Now, that would be done. We're done, right? No problem here. Well, we got a lot of issues because we don't have an x to integrate. And so what we actually have to do is solve for y squared from the original. You're always going to watch to the end before actually attempting this, right? We need y squared by itself. Move this over and divide by the 4. And y squared is equal to, and let me make sure I'm doing this right, 49, which we had saw earlier. And then I think it's going to be 49 over 4x squared. And all of that is actually just going to be tossed in directly. It's going to be tossed in directly right there. Integral from negative 2 to 2 of 49 times 1 minus 1/4 x squared. Notice that I took the 49 and moved it out to the front. Move it even more out to the front. And now I'm going to integrate. And so you get an x, and then here you get x cubed, now over 12, from negative 2 to 2. And we're on the home stretch here, actually. When you start plugging things in and stuff, you get 392 over 3, and that's your final answer. Okay. Whew. What does that have to do with disk method and shell method? I don't know. Actually, I have ideas, but I'm just not going to go through it with you because we got another one. 62070. Basically a copy-paste, except they have different shapes. So the base of a solid is enclosed by y equals 4 minus x squared and y equals 0. Cross-sections perpendicular to the y-axis and are squares. I highly recommend you pulling up the homework to see all that because I am not going to write it. It would just be a lot. So x, y, and z, what we have here is a parabola that's basically doing this. Now, this is all along the xy plane, okay? If you wanted to draw this in 2D land, it looks like this. And so all I'm doing is translating it into 3D. And so this is on the flat plane at the bottom. Y equals 0 is here. So then we got this guy here. And so I think what they're wanting to do in particular is all this stuff down there. Okay, cool. But they want the volume for cross-sections being squares and all that. So what they're saying is that at any point, that length from side to side is going to be the same as the height, making a square come up out of the page. Because see how that's a lot longer? So this will be a lot longer. And then over here, this will be like super long. So we're going to have super long. And then they come back down. And so all these squares here, last one, of course. Okay. And they kind of collide that way. This is a bad angle to be able to do all this. Just because I like you. I'm going to go ahead and draw it like this here. And so we have a parabola kind of like this. And then I'm going to come up with my squares. See, there's my base. So that's my length. And I'm going to come up with all these here like this. Okay. And so they actually kind of like touch one another down all the way to the peak down there. All right, so there's my shape. Cool. Find the volume. So volume is equal to integral of area dx. And so I need to find the area. Well, you know what's funny about these squares is that it's the x distance here, right? And so I'm saying that's 2x. And then it's a square, so it's 2x. And what's your square? What's your area here? It's 4x squared when you multiply. Base times width is height. And so we got integral of 4x squared dx. My x values are going to go from here to here. To find those x values here to here, actually, that's the part that doesn't make sense. No. These are my cross sections here. So what I actually need to do is start at 0 and go all the way until a y value, which I don't quite know. So yeah, don't attempt that. So that was bad. How high does it go? It goes until 4. So that's my y equals 4 right there. So 0 to 4, and it's not dx, it's dy right now. And so, just like the last problem, I can't leave it like this, because I need my dy's and dx's to actually be making sense. So I need to go and solve for solve for x squared. Y equals 4 minus x squared. Solve for x squared. I'm going to move these around, and x squared is equal to 4 minus y. That is what you plug in directly. If you were confused, join the club. I'm not saying that I'm explaining this the very best. Surely I am not going to be that kind of guy. But I'm trying hard to at least explain what I'm doing and how I'm going about it. At this point, you're integrating. The 0 goes away. It's 32. It's not that bad at that point. There's a lot going on. I get it. And I'm not assuming that you can graph all this stuff. But you know, that's why I did this problem at all, because I don't want you left hanging on the homework. Like, gosh, man, why didn't he do the hard problems? He always does the easy ones on his lecture videos. Well, no, I don't. I do the hard ones too. Like this guy, it's highly confusing. The one before it too. So I'm just trying to get a good survey of all that stuff. And although that's not perfect, try it out, work through it, and you can always ask me questions, of course. Thank you very much, and have a great day.